We'll begin our study of probability with some basics. First, a definition. Probability is the likelihood or chance that something is the case or will happen. So what we mean by is the case, if you had a room full of people and you wanted to compute the probability that two people have the same birthday, well, for that room full of people, the case is already there. I mean, it can't be changed. There are or there are not two people with the same birthday. That's the case. It's not. You're not waiting for something to happen. You're just got the probability that something does exist is the case. And then of course, or will happen. That's something we're used to thinking of probability as. Just a few areas where probability is used. In weather prediction, in traffic monitoring, where do we set up, traffic stops if we think there are people that are speeding or something like that. Health assessment, so based on certain factors, what's the probability of a particular person getting a particular disease? Of course, sports prediction, who's going to go to the Super Bowl? Politics, here we're talking about polls on particular issues or candidates. And all in the world of business. Soda manufacturers work with the probability that their machine will achieve exactly 12 ounces in each can. Obviously, it won't be exact, but they want the probability that it's within a certain range. And also something like restaurants that want to know the probability of a certain customer base so that they know how to staff their restaurant. Pharmaceutical companies, they conduct clinical trials to determine, the probability that someone will get relief if they take a particular drug or something like that. So, many areas where probability is used. Okay, so how is probability related to statistics? Well, probability is the basis for inferential statistics. And recall what we said before about our descriptive statistics. So we start, I'll write that up here, descriptive statistics. And we start by learning about, and as we have already, all these measures that we can take of a sample mean, median, standard deviation, things like that. These are ways to describe the data set. And then we want to get to inferential statistics. And the connection here is to go to probability. So we study probability, and that will lead us into our understanding of inferential statistics. So it is the basis for inferential statistics. Okay, so for our inferential statistics, we will be talking about these unbiased estimators, because recall, inferential statistics means that we're going to use sample statistics to make inferences, draw conclusions about population parameters. So we call these sample statistics, we talk about them in terms of whether or not they're an unbiased estimator of those population parameters. So for example, X bar, the mean, is an unbiased estimator of mu, the population mean. Sample mean is an unbiased estimator of the sample mean. That means it targets the sample mean. The population mean. This is the population mean. The sample mean targets the population mean. The sample variance targets the population variance. It is an unbiased estimator of the population variance. And we haven't talked about this yet, but we'll get to it. The sample proportion targets the population proportion. Okay? So these are unbiased estimators. Now, we've talked a lot about the standard deviation. What do we know about that? Well, the sample standard deviation does not target the population standard deviation. but the bias it has is relatively small in large samples. So since, as we've mentioned before, the sample standard deviation or the standard deviation has the same units as the data, and because its bias is relatively small, then we often use the sample standard deviation, I'm going to get a different color here, to estimate the population standard deviation. There is a small bias here in large samples. Okay, but we prefer to use this as our measure of variation because of the units being the same as the data. So that's the advantage of this, and the bias is relatively small. Okay, well, let's move on with just a few more definitions. Okay, an event in probability is defined as any collection of outcomes from a procedure. A simple event is defined as an outcome that cannot be further broken down into simpler components. And a sample space is all possible simple events for a procedure. It represents every possible outcome that we could have in a procedure. Okay, so let's look at an example. Here's a very simple example. We're going to roll a fair die, and we want to find the probability of getting a 2. Okay, so this is a simple event. Roll a fair die one time, and that's our simple event. And it's an event, it's a simple event, and we want to determine our sample space. So the sample space, recall, is all possible simple events for a procedure. So what are those? Well, we could get a 1, a 2, a 3, a 4, a 5, or a 6 when we roll a die. And we call this our sample space. We'll use a large S to represent that, and we'll put it in set notation. That means we'll use these curly brackets. So this is the set of all possible outcomes for this event. These are the simple events that are possible when we roll a fair die. Of course, fair just means that the probability of each possible outcome is the same. The probability of 1, 2, 3, 4, 5, and 6, they're all the same. It's a fair die. It's not set to land on any particular number. So we haven't even gotten this far yet, but I bet you could tell me the probability of getting a 2. When there are 6 possible outcomes and only one way to get a 2, you would probably tell me that it's 1 over 6, 1/6, and you would be correct. Let's just think about a few other examples. We could flip a fair coin. If you flip a fair coin, what would be the sample space? Sample space for that would be you either get a head or a tails. That's it. You flip a fair coin. These are your only choices. Okay, what if we flip a fair coin twice and record the results? So that sample space is a little different. Flip a fair coin twice, we could get heads both times. Or the first flip we'd get heads and the second tails. Or the first tails and the second heads. Or both coins could land on tails. So that changes when we flip a fair coin twice versus flipping a fair coin once. Okay, and we'll be talking more about this in other videos. Finally, I just want to mention our notation for probability will look like this. We'll say probability in parentheses, this is the event, probability of event A. That's what this means. The probability of event A. And you can put actual words in here, or for example, for my probability of getting a 2 up here, perhaps I would say, just for my own notation, I'd say probability of a 2. And I would say that's equal to 1/6. So that's how I can do the notation. Or I could say, in this one, probability of a head. I could put an H, I could put the word head if I wanted to. Probability of a head, of course, we know that'd be 1/2 if it's a fair coin. So we'll use this notation. It doesn't mean multiplication, P times A. It means this is our notation or wording, probability of event A. It's how we're naming our probability.